All right, for this next problem in section 12.3, number 2, this is asking us to simplify what are known as complex fractions. So as you can see in each one of these examples, we have a fraction divided by another fraction, okay, with this large fraction bar separating them. The bottom line is that this really is no different than what we were doing in question 1 for division problems. Just things are written now a little bit differently. So if I look at like 2a, I have 3/4, and then I'm dividing that by 9/2. Okay, so as a little side note here, we could just as well write that as 3/4 divided by 9/2. It's the same problem, okay? And what we've been doing, right, dividing by a fraction is the same thing as just multiplying by the reciprocal of what you're dividing by. And that's exactly what we're going to do in this problem. So I'll continue down here. What we're going to do is 3/4 times the reciprocal, which is 2/9. And now notice here, I have 3 and a 9, so this would give us a 1 and a 3. And then here, with the 2 and the 4, I'm going to get a 2 and a 1. So when all is said and done, I'm left with a 1/6. So that ratio there would be equal to 1/6. All right, cool. Well, we can do that same idea, just run that through for every single one of these problems, okay? So let's go ahead now and look at B. We have x squared minus x, all divided by x squared, divided by this expression, x minus 1 all over x cubed. Okay, so I'll first start by writing this as a division problem where I flip and multiply by the reciprocal, or sorry, I flip and then multiply here by what I see downstairs. So I'm going to get x squared minus x over x squared times the reciprocal here, which is x cubed over x minus 1. All right, and now before I get too crazy and start canceling stuff out, remember we want to factor everything that's factorable, and I can factor out an x there in that numerator. So I'll start there, and then the rest is going to just be the same. And I'll put this x minus 1 here in parentheses just for emphasis. And now we're in a position to start dividing some stuff out. So I have this x minus 1 here and here. And then x squared and x cubed. Okay, I can divide x squared by, well, itself. I'll get a 1. And then dividing x cubed by x squared, I'll lose 2 factors of x, leaving a factor of x behind. And so then, combining everything that's left, I'll get an x times an x up top, and that's an x squared. And I just get a 1 in the bottom, and so here my answer would just be x squared. All right, cool. For the next one, C, we have x squared minus 1 all over x, and then that's being divided by just x plus 1. Okay, now to write this so it looks like a problem we've already done, go ahead and just think about the x plus 1 as an x plus 1 over 1. So think of it as a fraction whose denominator is 1, and now we'll just be up and running doing the same thing we've been doing with the others. Okay, so I'm going to do the thing upstairs, x squared minus 1 over x times the reciprocal of what's downstairs, and that's going to be 1 over x plus 1. All right, now x squared minus 1, that's a difference of squares pattern. It's x squared minus 1 squared, so I can factor that as x minus 1 times x plus 1. I'm dividing that then by x, and then multiply that by 1 over x plus 1. And I'll put that in parentheses. And then we can go ahead and divide out this common factor of x plus 1. And what are we left over with? Just an x minus 1 on top, because these are, the rest of it is just our 1s. So there's that. And then downstairs, just x times 1, which is just x. And so there we go. All right, on to D. Pretty similar here. You got some a over a minus b, and then we're dividing that by b over b minus a. All right, so as usual, we'll start by just writing this as a over a minus b times the reciprocal here, which is going to be b minus a divided by b. All right, and now a minus b and b minus a, right? These are the same letters, just the order of subtraction is reversed. So what I'm going to do then is leave the first fraction alone, and then I'm going to flip this and put a negative in front. And that's a b, and now I'm in a place where I can go ahead and divide. So if I divide here by a minus b, I'll get a 1 there and a negative 1 there. And so I'm going to be left with a negative a on top and just a b on bottom. So I'm left with minus a over b. And that is it. Okay, and then for the very, very last one here, this is e. You got 2 minus x over x minus 2, and then we're dividing all of that by 4 minus 2x all over x squared minus 4x plus 4. Okay, so I think what I'm going to do here, because I'm a little shy on room, okay, I'm going to make a little space down here and solve it here. Okay, so here's part E, and so here's what we can do, right? We can just start out by multiplying by the denominators. I'm just going to copy the problem here. Sorry about that. Kind of ran out of room. So this is going to be 2 minus x over x minus 2 times the reciprocal here, and this is going to be x squared minus 4x plus 4, all divided by 4 minus 2x. Okay, and so now that we've done that, let's go ahead and factor everything in sight that we can. So I have a 2 minus an x and an x minus a 2, and here I can go ahead and factor out a 2 in the denominator, and that's going to leave us with a 2 minus an x. And then upstairs I have this trinomial, so I'm going to factor it as the product of two binomials. So this would be x and an x to build the x squared. And then for the 4, well, a 2 and a 2 can be used to build a middle term of negative 4 if I make both of these negative. All right, and so now let's go ahead and do some divisions. So we're going to get what? Well, notice I have a 2 minus an x and a 2 minus an x right there. So those will divide out. I also have an x minus a 2 and an x minus a 2. So this and this would divide out. And then that's just going to leave us with an x minus a 2 on top and a 2 on the bottom, and that will do it. All right, great. Well, that's going to do it for question 2. Thanks.